Now that you know how to solve different kind of equations, let's take a look at solving percentage problems when the original quantity is unknown. Let's start with some general strategies. When the original amount is unknown, we can label it with variables like x or t or p, whatever variable you would like to use. And then we set up the equations. Remember, percentage of means multiplication problems. All right, so let's take a look. The gender wage gap varies by occupation. Female waitresses, on average, earn 82% as much as male waiters. So if a typical female waitress earns $12 an hour in New York City, what does a typical male waiter earn in New York City? In other words, what wage is $12 per hour 82% off? All right, since we do not know how much money a male waiter in New York makes per hour, let's call it X. What we do know is that $12 per hour represents 82% of X. Do you remember how we talked about what off means? 82% of X means what? 82 over 100. The off means multiplication of X. And the is means equals. So that tells you how you can translate words into equations. So you have 12 is equal to 0.82x. That's the multiplication giving you percent. And now we've seen how to isolate the variable x. You'd have to divide both sides by 0.82. And so that would be your answer. You also know how to do this long division, so you can go ahead and do that. So that'll be about $14.63. So male waiters earn $14.63 per hour versus female waitresses earn 82% of that, which is $12 an hour. It's always important to end your answer in words. So the male waiter makes $14.63 per hour. All right, let's try this one on your own. Pause the video and see what you can do. Car dealer marked the price of a new car down by 8%. And the sale price was $18,000. What's the original price? Since we do not know the original price, we're going to call it X. Sometimes drawing a picture, a visual aid helps because then you understand what the problem is all about. So let's say X be the original price of the car. So X is this original price. Now the car dealer marked the price of the new car 8% down, and the sale price was $18,000. So this is my sale price, which represents 8% less than the original amount. So how can we write that in equation form then? 18,000, the sale price, is the original price X, and you're taking this red portion away. So 8% of X taken away. Taken away means subtraction. Percentage of means multiplication. So now you have an equation and you can solve. So simplify like terms and then divide both sides by 0.92. You know how to do this division, so I'll let you finish that and verify that it really is approximately $19,565. All right, so here's some information. Sometimes information is given to you in form of a pie chart, and you have to understand what these different percentages mean. The pie chart here is representing the ethnic composition of University of Wisconsin College's students. There are 1,118 students that are non-white students, and they're asking you what's the total enrollment of the colleges. So look at all the breakdown. African Americans, Hispanics, Southeast Asians, American Indians, and white. So 92% of the students are white, and the rest of the demographics are broken down in these percentages. How do we figure out what the total number of students are? We know that this is 5 plus 3, 8. So 8% of the students are 1,118. So from that, we can figure out what the total number of students are. So we'll say X is the total number of students since we do not know that number. And then 8% of that X is 1,118. So divide both sides by 0.08, and there's your approximate number of students. So there's approximately 13,975 students in the University of Wisconsin colleges. Sometimes you'll see equations appear in solving proportions. So let's take a look. A proportion is an equality statement between two ratios. So when you take two ratios and equate them, it forms a proportion. Proportions show up many different places. For example, when you want to find unknown lengths in similar geometric shapes. Why is that? Because two objects in geometry are called similar if their corresponding sides are good, proportional. So, for example, if you have a triangle and you have a same triangle blown up twice as much, then all the lengths in the bigger triangle are twice as big as the little triangle, and so on. You also use proportions when you're converting, for example, from feet to inches, or from feet to centimeter, or centimeter to kilometer. You also use it to compute rates, like somebody getting paid so many dollars per hour, or the price of gas going up so many dollars per gallon. You also use it in cooking when you are trying to make a batch of cookies, which is a larger batch or a smaller batch than the recipe that was originally given to you. So we're going to work through a few examples so you can see how this works. So let's take an example. Paul ran a marathon, which is 26.2 miles in 3 hours and 7 minutes. At this rate, how long will it take Paul to run a 10K race, which is 6.2 miles? So remember, when they say at this rate, that means at the same speed. If Paul were to run consistent speed as he did for the marathon for this 10K race, then they're asking you how long will it take. Okay, so remember, when you are saying the rate, that means distance over time ratio. So we're basically comparing two ratios. So Paul ran 26.2 miles in 187 minutes. Why 187 minutes? 3 hours is basically what? 3 times 60 minutes, right? 3 times 60 minutes is 180 minutes, plus 7 is 187 minutes. So 26.2 miles in 187 minutes, 6.2 miles, we don't know how long, so we'll have to call t as our variable. T represents how long it will take him to run 10K race. When you're setting up proportions, it's very important to pay attention to units. If you put miles on numerator and minutes on the denominator on one side, you have to do the same with the other units. This will allow you to set up correct proportions. Now, we want to solve for this t. So first, you can make common denominators. So you have fractions now that have the same denominators, which means that the numerators would have to equal, which is basically the same as saying cross multiply. Some of you might be used to hearing the words cross multiply. The cross multiply works. This is the reason behind it. You're making actually a common denominator. And then solve. Since you're trying to isolate the t, you have to divide both sides by 26.2 and then get the answer. You can do the division on your own, and you'll see that that's the same as 44.3 minutes. All right, take a look. A cookie recipe calls for 1½ cups of flour, 7 ounces of almond paste, and makes 2 dozen cookies. How much flour would be needed to make a huge batch of these cookies that utilizes 90-ounce can of almond paste? Also, how many cookies would this make? So let's see how we can figure this out. There are two ratios here, so we're going to set them up both. So take a look. Let x be the number of cups of flour, and let y represent number of cookies. So flour to almond paste ratio was what? 1½ cups of flour to 7 ounces of almond paste. Now we want to use 90 ounces of almond paste, and we want to know how many cups of flour. So again, you can cross multiply if you want, or since you only want to solve for x, we just want to get rid of 90. So it's divide by 90. To get rid of it, you would have to undo division, which is multiply both sides by 90. and then you get 19.3 cups of flour. All right, cookies and almond paste. You can make 24 cookies with a 7-ounce paste. So if you want to know how many cookies you're going to make out of 90-ounce can, again, multiply both sides by 90, and you'll get about 309 cookies.